Hey guys, I'm going to make a quick video for you. This is for the first lab in AIT 2701, and as I promised you, it's just going to be a very quick general video on the instructions on basically what you're going to be doing in the lab when you come in, and give you some explanation about the PLCs. For a lot of you, it's going to be the first time you've ever been around one. And this is a very inexpensive PLC. It's very good for training purposes. It's made by Automation Direct. It's called Click, and that's the series name for it. And it's a pretty good little PLC. It does everything we need it to do, particularly here in the lab. But I have seen these out in industry as well for some less than critical applications, you might say. They're just a good general purpose PLC. But I want to talk to you a little bit about some of the components and what you're going to be doing in the lab real quick. And everything is step-by-step instructions in the lab manual. But I thought this might give you a little jump start on it. But again, the lab manual is going to step you through everything, and it's very critical that you go through it. This is the PLC right here, okay? Now this is the power supply that we hook 120 volts to. And we hook 120 volts to it because it gives us a 24 volt output that runs our inputs for this PLC. Okay, this is our power supply. This is the processor itself. This is the actual PLC itself. Okay, this is the brain. This is where all of the decisions are made based on the logic, and I'm going to be showing you some logic a little bit later in the video. But this is the PLC. This is where the program resides. We write a program, we download it from our laptop or our desktop PC, and we download it into the processor, and only one program at a time resides in the PLC. Okay, so this is the processor. Now this module right here is an output module. On the PLC, this particular PLC itself, we have input sections right here, the input section right here, and then we have the output section. Now, the reason we have a separate output module over here instead of using these is because these are for 24 volts. We're going to have 24 volts, 24 volt input devices, okay, delivering 24 volts to the input section. But our output devices, which is these lamps over here, they're 120 volt. So obviously a 24 volt is not going to light up the lights like we need it to. Okay, so we need a separate module that deals specifically with 120 volts. So we will tell the PLC to say when we get an input, instead of delivering an output over here for the 24 volt section, we'll address it to where it says, hey, go over here to this other module and then give me an output signal off of this output module, and we will address that, assign it a output address, and the PLC will know where to go to deliver the output. You could have several of these output modules stacked, and it's that address that you're going to give it to tell whether does it come out of this card at this point right here, or maybe another card at a different point. So that address is what tells you where the signal comes out and also where the signal comes in. But my point is that the 24 volt input signal coming from our input devices is going to land right here, and instead of a 24 volt output, which we can't use with 120 volt lamps, we have a designated 120 volt output module to light up the lamps right there. You'll see how all this comes together a little bit later, particularly when you come back to lab. But anyway, this is our, like I said, our power supply for the PLC. This is the PLC itself, the brains, the central processing unit, and here is an output module that we're utilizing as well. On the power supply, we give it 120 volts. It gives us 24 volt output. We route that. This is already done for you. You don't have to do this in the lab, but we route this over to the PLC so that it can power it. Obviously, and if I take the power out like that, it kills it. I'm not sure if you can see how well you can see that with the camera, but there we go. We got lit it back up there. So, and over here is a separate power supply. Now this power supply gives us 24 volts for our input devices. So remember, this 24 volt is just to power the processor. Okay, it doesn't power any of the input devices or output devices. This is just for the PLC to be able to turn on and off. Okay, this power supply here is separate, and we are running our 24 volt positive. This is the positive terminal coming out right here, and we are routing it down to here, and it will go out over, and the 24 volt will hit each one of our input devices, okay, and it will stop there at the input device. All right, and each one of the input devices has a conductor routing it back to a specific terminal here on the terminal strip. This is one landing at number 1, 2, and 2, and so on and so forth. Okay, but we've got basically 8 input devices, and we have 8 input ports, or points, you might say, on the PLC. So we are delivering 24 volts out to each input device, and when we turn an input device on, that signal will pass through and come to a particular point. Like, for example, I'm not sure you can see it, but this is input number 5. When my switch is turned over to my selector switch is turned over to the left at number 5, we get an input signal. That 24 volt goes through the switch, through that set of contacts, and lands at number 5. So here we are sitting there waiting with our 24 voltage parked right there waiting on us. So how does it get to the PLC? Well, that's one of the things you're going to do in the lab. All right. So you're going to be given a couple of connectors like this. Okay, the long one here is the input device terminal, and this is the output. Notice they sort of match up in size too. Okay, how about that? All right. So anyway, you're going to take these, and you're going to cut conductors. Excuse me, and you're going to terminate them. Okay, you're going to strip them and put them in their respective places. Okay. And you're going to get enough wire to run from here to down here. Now, I would suggest that don't make this a tight fit, okay? Give yourself a little slack, because if you don't happen to get back on the same trainer, sometimes these PLCs are moved over a little bit and it'll stretch your wires kind of tight. So give yourself maybe 2 or 3 extra inches of slack, okay? But what you're going to do is you're going to cut the conductors. You're going to print a wire label. We've got the wire label printer for you, and this is basically a heat shrink sleeve, and it prints the wire number on there. Okay, and in this particular example, we got X008. Okay, so that wire is connected over here to this X008. Okay, so you'll park 8 right there, and then you'll run it to this terminal. Now, you're going to be given a wiring schematic, so you'll know where each one of these parks. Okay, so don't worry about trying to remember this or anything like that. You're going to have a schematic, and you'll build your harness based on the schematic. Okay, and what you're going to do is you're going to basically route all of your inputs down here from the terminal strip, because remember, our signal's coming from our real-world discrete output devices. Okay, and it's going to park right there. We have to make that connection from the terminal strip up to the PLC, so the PLC can get the signal of 24 volts as an input. Okay, and then you're also going to do the same thing for the output. Okay, so because in our program, one of the programs that's already written for you that you're going to pull up in the first lab, in that program, it will deliver an output, and so it's going to deliver an output to this terminal right here. But we've got to get it from here through our fuse block out to our lights. Now, from our fuse block all the way out to our lights, it's already done for you. All you've got to do is make that connection between here and the fuse block, and don't forget to pop your fuses in. They're numbered, which slot they go in, 1, 2, 3, 4, 5. So all of this is laid out for you in your lab manual. So make sure you follow instructions very carefully. If you have any problems, by all means, get a lab instructor, and I will be out here sometimes too. So just get me or any of the lab instructors, and we will kind of help you through it to get you started. I'm having you make these harnesses because in the early days of the AIT program, a lot of students weren't understanding, when I push this button, why does that make the light come on? Or if I push this button, how does that give me an input signal? I don't understand that. So to make that connection, to kind of clarify that, we developed this wiring harness exercise. So that's what you're going to be doing. So for right now, though, what we're going to do is you're going to make a couple of harnesses, and then you're going to pull up a program and download it into the PLC, and then you're going to see when you press these buttons, the sample program that is written for you is going to deliver outputs for you, and you're going to kind of see it come together in a very basic way. That's the whole intent of this lab exercise. So with that said, just go on in the lab, and one other thing I did fail to mention, when you do make your harness, these little ends right here will be staked on, and they are really good for the fact that when you put them behind a terminal screw, whether they're an output going there to the fuse block or if they're going back here. These are really nice because you wind up with frayed wires a lot of times, and you have to stop and twist them. Sometimes you have to restrip them because they've been stuffed in these, and all the conductors didn't get here, and they wind up fraying. This kind of encapsulates all the conductor strands and puts it into one point, and it's real easy just to get it in and out and tighten down on it, and a lot easier. So that's the reason we have you stake those on the ends of the conductors. But again, all of that is in the lab manual. So that concludes this part as far as the hardware and kind of what you'll be doing with the wiring harnesses and things like that. So that's going to conclude this part of it, and I'm now going to show you the software. I'm going to pull it up and let you see that and kind of how that works. And then that should conclude everything, and this should make it fairly easy for you to go through the first lab for those who have not done it yet. So anyway, I'm going to continue to make videos like this so you kind of understand what's going on and make it a little easier during these times of COVID. It's just, and also with the flash crashing on us. So that's going to take care of this part of it. Be sure to watch the next part so that it covers the software, and we will talk to you a little later. Thanks for watching. Okay, so we're back. This is going to give you a little demonstration on the software, kind of how to navigate it. You're not going to do a whole lot other than just open a program on the introduction lab, but it will give you an idea because of some of the other features too, because you will be using those starting with the second lab. So I just want to get you familiar with it and put it up there on the screen. First thing you're going to do is you're going to open up the Click Software icon on the desktop of the computer in the lab, and it's going to open up, and then at some point you're going to be told to upload or download a program into the PLC. But this is what the software looks like. Okay, now a couple of things I'm going to talk to you about very quickly. Number one, this is ladder logic as opposed to relay logic like you learned in 1401 and 1501. Okay, this looks very similar. Okay, you have rungs, horizontal lines, and you also have rails that represent the power and the neutral side. They are just representative of that because that was how PLC programs were designed so that the electrician can understand it. Electricians understand relay logic, and so it transfers very nicely into ladder logic. Okay, you have a lot of the same contact symbols or input signals and output signals. This sort of resembles a coil as an output device. Okay, and these sort of resemble normally open contacts or normally closed contacts, whatever the case may be, that serve as input devices. Okay, but this is these are your inputs and your outputs. Okay, and you can basically, this program is going to simulate a pump starting system, and it's not anything real complicated about it, but again, it's just so that you're able to download the program, press a push button that we have named the pump motor start. Now, you'll learn in the part where it's a nomenclature, you can name it anything you want to. You could name this, you can name anything. You can call it a doorbell switch or whatever. It doesn't matter. You give that nomenclature to it. And then same with the output over here. But we've called this one the pump motor start PB, which means pump motor start push button, so that when we push a button on our trainer, we will highlight, you'll see a highlight if it gets the input device to that terminal on the input portion of the PLC that you wired with your wiring harness. You should see this start to turn green. Now, I'm not live with this right now with a trainer. I thought it would be easier for us to be able to see this, and so we're gonna basically just use this as an example. But you'll see it turn green, and if it turns green, then you'll have logical continuity, and if you've got this input, then you're going to have this output, which is a pump motor starter, meaning that our output device is wired to that terminal on our output module there in the trainer. Okay, same thing here. It's either this one or this one right here. Now, this is a seal-in. Okay, it's got the same address, and you're going to learn all about addressing. It's not what this lecture is about or this demo is about. But here, this is the same address, so that this is your ceiling, okay? So again, I just want to get you familiar with it a little bit. You're going to be pulling the program up on the PC, on the tower, and you're going to download it into the processor. And you're going to find a couple different ways to do this. You can go into, I will open it up for you real quickly. You can open up this tab up here. It says PLC, do a little drop down menu, and you're going to write the project. Now, there's another option here that says write data. We do not want to write data. That is just the data that will be written. And so we want to write the entire program. So we're going to open it up, and then we're going to write the project into the PLC. That's the same as downloading the project into the PLC. And with it being connected, what it'll do is it will download the project from the tower of the PC into the PLC, and it will overwrite anything that's in the PLC because, as we've stated before, there's only one program and there's only room for one program in a PLC. They're designed that way specifically, and it's mostly for safety reasons. But you write a project into a PLC, and then you can start by running the program. And once you've downloaded that program, it'll ask you if you want to run the program. I think that you can also go over here and it'll ask you if you want to run the PLC or run the program as well. And that makes it live, okay? And then you're able to, this is just a sample program. You're not going to be writing anything in this program from this first one. However, you will be from the second lab on out to the rest of the class. So I just want to give you an idea of what it is you're going to be dealing with. And I'll go a little bit more specific with some of the instructions as we go along, but I just want to give you an idea of what the software looks like. This software is sort of the translator between you and the computer and the PLC itself. Okay, so it takes your instructions that you're putting in here in your rungs of logic, okay, and it takes it and it translates it into what PLC can understand, and it will execute each line of this program. The PLC executes one line at a time, okay, and it does it extremely fast, okay. So we're talking about within milliseconds, okay. So it will execute this first line of logic first, and then it will immediately look at this line of logic and see if there's any logical continuity between here and there. It'll go to the third one, the fourth one, and it just rapidly goes until it hits the end of the program, and then it comes back up to rung number 1 and starts the process all over, and it does it at just lightning speed, really fast. That's one of the advantages of PLC. It does it extremely fast, okay? And it does not have to have logical continuity across this one before it moves on to this one. It will just look at it and say, hey, do I need to do anything? If the push button's not pressed, it says no, there's no output, move on, okay? And just moves on very, very quickly. But that, in a very simplified way, is how the PLC runs its program, okay? But again, you're going to learn a lot more about all of the software and everything. I just wanted to give you an idea of what it's going to look like. So that being said, come on into the lab, and if you have any questions, get a hold of me. I hope this has helped. I'm going to be doing more of these along with some additional lecture videos, okay? But like I told you before, the majority of your information is going to come from the textbook, so make sure you read the assigned reading, okay? Other than that, we will talk to you in the lab. Thanks a lot.